Hello, everyone, and good morning. My name is Tiffany. I'm an educator here at the Aquarium of the Pacific, and I am joined by my friend Allie in the studio with me, who is putting behind all of the magic that you see going on behind me. I'm not actually swimming with all of these fish right now, but rather I'm in front of a green screen, and then she's able to control and change what is going on behind me. Now, we are going to be learning today about the science of SCUBA, which is crazy. There's so much science that goes into scuba. So not only do you have to know all of the technical things, but scuba diving also takes a lot of skill. So we will be able to dive into that. If you have ever taken a chemistry class, then this will be just a little quiz for you. You know all about those gas laws. But we want to make sure that we are answering any questions that you have and that we are interacting with one another. So you are able to text us if you are watching this live on Friday at 10 a.m. You are able to text us in live. That number is 562-286-1838. So you're able to text us in any observations that you see, any questions that you have. If you are watching the recording, we still would like to hear from you. You can instead email us at live@lbaop.org. We look forward to hearing from you. All right, so right now we are looking at our tropical exhibit here at the aquarium. This is modeled after a real dive site in Palau. So our divers, our volunteer divers here at the aquarium, love going in this exhibit in particular because the water is going to be warmer than it is in some of our other exhibits, like our Blue Cavern exhibit is modeled after waters that we have here in California. So that is going to be much colder. I'm kind of a wimp when it comes to diving, and I'm going to want a very thick wetsuit if I'm diving here in Southern California. But here it is much, much warmer. You can have a thin dive suit or possibly not even one at all. But we need to think about what adaptations do these fish have that we clearly do not have that allow them to live in this environment, and how do we change by using different pieces of technology? How do we change so that we are able to kind of become one of their world for a time being? So watch these fish for quite a couple of moments, and if you're in a classroom, go ahead and maybe talk with one of your partners. What do you think, what adaptations, what traits do these fish have that allow them to live in the water successfully, but what are we missing and how do we compensate for that? I've already kind of mentioned one. If I were to go diving, like in our California waters, I would be much too cold, but obviously the fish that live there are just fine. So what do they have that we are missing? One thing that we see a lot of movement. We can see the zebra shark gracefully moving by, the rays gracefully moving by. This fish kind of swam up on us pretty fast. Are any of us kind of trained Olympic swimmers? Anyone? Anyone out there? Anyone watching? No? No? Yeah, me neither. When I swim, I can swim, of course, but not very fast. But while you are exploring the ocean, you don't want to waste a ton of energy with our lame swimming methods. Look at these fish as they seem to effortlessly glide through this water. What are they using that helps them to swim so well? Their fins. Their fins are helping them, are specially designed to help them swim through the water faster than what we can naturally on our own swim through the water. Now, as they are swimming through the water, have you ever just opened your eyes in a pool and try to look around? I frequently do that without goggles. And it's pretty blurry. I mean, for the most part, you can see. But if that was your life 100% of the time, it could probably be pretty hard to find food, right? So the fish have eyes that are adapted to be able to see underwater, so they are able to know, okay, that's just a rock versus this is a fish that maybe I want to go hunt down and eat. But when we go into the water, we're going to need something to help out our eyes. And we also mentioned these fish are obviously adapted to living in the different temperatures that they do versus we would possibly be pretty cold. Maybe not in tropical waters, but in Southern California waters or anywhere else, definitely cold. And then these fish are able to kind of float if, like, this fish isn't moving too fast over here, so he's almost kind of like floating around. How on earth do they do that? Let's go ahead and take a look at pieces of dive equipment that you and I can use as people and relate them to what the fish naturally have. So I have a friend here, Sherman.
Hi, Sherman.
Sherman is much taller than I am. I might have to move him around so that we're able to see everything that Sherman has going on. But first and foremost, one of my main problems when I'm going diving, if I were to go to free diving, it's not going to be super fun. I can maybe hold my breath 30 seconds to a minute. I don't know about you. Maybe test it out right now. We'll see. But I want to really explore the depths of the ocean, and something that's going to help us do that are the tank, and then here, the regulator. This is the part that you put into your mouth. So the tank and regulator are going to be able to supply you with air while you are on your underwater adventure. Versus the fish have gills. They will have their mouth open. They have different mechanisms to get the water into their body, but then they will filter that over their gills. You usually see their little gill covers there on the sides of those fish. Whoop. So here's Garibaldi, and here's that Garibaldi's little gill cover there. So the gills are going to be underneath this, and they look kind of like feathers. So the water is going to be filtered over those gills, and they still actually are breathing oxygen like we do, but they are taking the oxygen out of the water and filtering that over their gills. We instead, when we go underwater, are going to have a tank, and that tank is going to determine how long we are able to stay underwater, because that tank will eventually run out, and you don't want to be stuck underwater without a tank. Hopefully you got some buddies that can share with you if you do. All right, so breathing, that is kind of one of my main concerns. One of my other concerns, let me scoot this guy back and see if we can fit him in. You can barely see right here. But being able to see, we have these goggles. Now, you don't want water trapped in the goggles, because then that kind of defeats the purpose, right? You have the salt water burning your eyes, and then you still have that same poor vision as you do underwater. But rather, we use those goggles to trap in air, because our eyes are best adapted to be able to see through air. So we trap in air in those goggles so that we are able to better see underwater. Now, we probably still don't have the best eyesight underwater compared to some animals that are adapted to live in that environment, but we could still see pretty well compared to what we would without them. And if you ever do get water into your goggles, you kind of flip your head back, blow air through your nose to get that water out of your mask, because you want to keep that relatively water free so that you are able to see. So, breathing underwater, seeing underwater. What's this for? This is for warmth underwater. So again, you might not need this is a 3mm suit. If I was diving in California, I'm going to be honest, I'd probably use a 7, because I would probably still be cold even with the 7. But you would want to use this in warmer waters, this 3mm. I know a lot of our divers use 3mm here at the aquarium. Some 5s for those colder waters. But this is going to help us to stay regulated and to stay protected, because what do we do on land if we get cold? We kind of are shivering and our muscles are contracting to try and keep us warm, but you don't really want to do that when you are in the water. That takes away from your experience. This is going to help to have just a more comfortable experience. All right, now I said that those fish were moving along so gracefully through the water, and if I was just swimming on my own, I would probably get tired pretty quick. So we have fins that we can put onto our feet to help us just move more water as we are traveling along. So by moving our feet, we don't even have to move them as much as we normally would when we're swimming, because this will get us by a lot faster than it would with just our bare feet. Okay, I think I covered everything except a handy piece of tech called a BCD. So that stands for Buoyancy Compensation Device. So I pointed out that some of these fish, let me move Sherman over. I mentioned that some of these fish, some of them are kind of swimming kind of fast, but some of them kind of float around a little bit. How are they able to float? They have something called a swim bladder that helps determine where they are in the water column. And that swim bladder is filled just with oxygen, just like if you were to kind of hold your breath in your lungs almost become kind of like a swim bladder. And that is how they're able to float and determine if they want to go up or if they want to go down in that water column. So we have a piece of technology called the Buoyancy Compensation Device that helps us to determine where we are in the water column as well. All right, so I mentioned the Buoyancy Compensation Device. Buoyancy. That's a vocab word for you high school and middle school students. What is buoyancy? Let me push Sherman off here. What is buoyancy? So when an object is immersed into a liquid, there is an upward force on that object from the liquid. That is buoyancy. Now, the density of the object also plays a role whether or not that object is going to float. If the object is more dense than the surrounding liquid, then that object has negative buoyancy and it is going to sink. Now, if that object's density is less than the surrounding liquid, that object has positive buoyancy and it is going to float. So let's do a little experiment here. I have some water and I have some objects. So I have cute little toy fish, I have a coin, and I have some small beads. Now, before I place them into the water, here's my water here. Before I place them into the water, I want you to already make your hypothesis. Is it going to float or is it going to sink? Does it have that positive buoyancy or is it going to have negative buoyancy? Okay, let's start off with the little fish. So quickly, tell someone, do you think it's going to have positive or negative buoyancy? Before I put it in, no cheating. Positive buoyancy. Okay, now let's go with the coin. Again, tell someone, no cheating. I'm going to drop it in. 3, 2, 1. Wow, that went to the bottom really, really fast. Definitely negative buoyancy. Now all of these beads, they are made out of plastic. There's a pretty big hole through the middle of them. Let's drop them in and see. But first, remember, make your hypothesis. What do you think? Is it going to be a negative or positive buoyancy? 3, 2, 1. Did you see that? So initially, with their fall and with gravity kind of pushing them along, you saw that they sank a little bit, but they eventually did float. Now there is one bead that does have negative buoyancy and did sink, And actually looking at that bead now, its little hole is clogged up with some clay. So that was a little trick there with that bead. But the rest of the beads do seem to have positive buoyancy. Now you can try that little demo experiment with random objects around if you're in a classroom or around at home. Just make sure that they're able to get wet in water. Please don't throw your phones into the water. Okay, so that was our little buoyancy demonstration. Now, we had already mentioned how does that fish determine where it is in the water column, and that is all because of its swim bladder. And its swim bladder, again, is going to be an organ just specifically designed. They have that special adaptation of basically having almost like a lung, like us, but just filled with oxygen, and they can release air. It has nothing to do with their breathing, but they can release air or take in more air to kind of float or sink through that water column. Very cool. Okay, now let's talk about divers and their buoyancy. So, if a diver with none of their gear on, not even the wetsuit, went into the water, humans have actually a neutral buoyancy. We will just kind of, if you've ever gone into a pool, just kind of floated there on your back, you're not completely on top of the water, but you're not completely sinking down in the water either. You're able to kind of just float on your back. Your head's kind of still at the surface, so you're able to breathe. Some of your body is a little bit underwater, but we have a neutral buoyancy with nothing on. Okay, now let's start adding on some of our dive gear. Do you think this dive gear is going to have a neutral buoyancy, positive buoyancy, or negative buoyancy? So let's first look at our wetsuit. Our wetsuit made out of neoprene. It's pretty squishy, feels pretty light. Do you think it's going to have a positive or negative buoyancy effect on us as a human when we go diving? Share with a partner. What do you think? It is going to have a positive buoyancy because what you ideally are doing is actually trapping some air in between you and this wetsuit. That your body heat will start to warm up. It also has water that gets trapped in there. That your body heat starts to warm up, and that's kind of, you create your own little heated blanket there. Okay, another piece of equipment that, let me see if this guy actually has it on. I don't think he does. But when we're diving, since we are neutrally buoyant, we're just going to be at the surface of the water. We don't want to just stay at the surface of the water. Everything that we want to look at is going to be down deeper in the water. So we are neutrally buoyant. Now we just put on this wetsuit that is positively buoyant. How do we get down? Divers will often have a belt of weights. Now, are those weights going to be positive or negative buoyancy? Pretty obvious. Those ones are going to have a negative buoyancy to try and help us to sink down. Since our natural body and now our wetsuit are kind of telling us to float, we need something to help us sink down a little bit more. Now, our tank. What is our tank's buoyancy? It is actually going to change as we are diving, because when we first start off, our tank is going to be filled with air, but as we are using that up, it becomes drained of that air. So it first acts kind of similar to maybe like a swim bladder of like a fish, but as we are draining it of air, it becomes void of that. So it changes between positive and negative buoyancy. Okay, and that fancy piece of tech we had talked about before, the BCD, that also can change between positive and negative buoyancy depending on how you set it and how you use it, because that is basically our artificial swim bladder that the fish has, so that we are able to kind of decide where we are at in that water column. And is there anything else that you can think of that might change the buoyancy of a diver? Our lungs. So as we breathe in, our lungs can almost make us float a little bit, and then as we breathe out and get that out, we can sink a little bit as well. So it's almost like a little natural swim bladder that we have naturally as well. Okay, so we talked about our buoyancy of our divers, but there's something else that is very, very important while we are diving and for diver safety, and that is pressure and decompression of divers. So when we are standing perfectly at sea level, we have exactly 1 atmosphere of pressure on us. Now, if you were to hike to the top of a mountain, that is less than 1 full atmosphere of pressure. But then if you're standing at sea level and you start to go down into the ocean, now you are getting more pressure on you. But does air weigh the same as water? No. Water is going to be more dense. So we have all of this atmosphere on top of us, but if we had that much water on us, that is a lot more than 1 atmosphere of pressure. So as you are moving down through the water, you're getting more and more pressure on all of your organs and your lungs. We're specifically going to talk about pressure as it relates to our lungs and our breathing. So if we dove down to 60 feet below sea level and we had a breath of air, and then for whatever reason we decided to hold our breath and then come up to the surface, what would happen? What would happen? You know what? Let's draw a picture to get a better idea. Okay, so pressure. Think about if you have taken chemistry, this is all about Boyle's law. So as pressure decreases, the volume of that gas is going to increase. What on earth does that mean? The reverse would also be true. So pressure increases, volume decreases. Okay, so they have that type of inverse relationship. So we are diving. We're going to be down at 60 feet. Okay, and we take in a full breath of air. Okay, this is the air in our lungs. Now, there is more pressure down there at 60 feet than there is at sea level. So what we expect as we rise, so pressure starts to decrease, the volume of this gas will increase. So what happens at sea level is that the volume of this gas has increased and potentially your lungs could rupture. So it's very important that when you're diving, when you're down at depths and you are rising up, not to hold your breath, because the volume of the gas inside of your lungs will expand as that pressure is trying to make your lungs smaller, right? But as you are rising up, that pressure lets off and the volume of your lungs gets larger. So don't hold your breath when you are rising in the water column. Okay, so Boyle's law. Pressure goes down, volume goes up, or the reverse is also true. Now, there's something also known as Henry's law. Henry's law relates to the amount of dissolved gas in a liquid. So Henry's law, dissolved gas in a liquid is equal to the partial pressure of the surrounding liquid. So when you are diving and you have your gas tank on and you are breathing through that, it isn't just pure oxygen. And what we're breathing now on land also isn't just pure oxygen. It's going to be about 78% nitrogen, 21% oxygen, and then 1% other, which is what we are naturally breathing, and that is what will be in your tank as well. Well, when you are down in depths, that nitrogen, because of Henry's law, that nitrogen starts to become dissolved into the tissues of your skin. So as you are rising, if you rise too fast, that dissolved gas doesn't have enough time to become undissolved. So if you have ever taken scuba diving lessons, you might have heard of like the term like gassing off. So as you rise, you need to give your body time to readjust to that new pressure. If you rise too fast, you can get decompression sickness, and some people get dizzy, lightheaded, headaches, rashes, all sorts of bad things can happen in addition to just feeling kind of sick if you give your body enough time to adjust through those different pressures. So all of that is super important. And as you can see, there's a lot of science that is involved in diving. Let's go ahead and take a look at our trop exhibit again. So our divers here are very, very skilled divers. I actually wouldn't be qualified to be one of these divers here at the aquarium. They have to be very, very skilled rescue level divers with many, many dives underneath their belt so that they are able to, one, know all of the science behind diving, but then also help out their buddies as well if anything were to ever happen. And again, if you have any questions about this, you can text us in. We are almost out of time, so it might be better to email us any questions that you have at live@lbaop.org. All right, it has been fun learning about the science of scuba diving with you. If you haven't taken a high school level chemistry class, hopefully you learned a little bit about Boyle's law and Henry's law, those important gas laws, and how they relate to the very fun sport of scuba diving. All right, until next time, we will see you. Have a good weekend.